Hi, this is Ms. Leminski from Edina High School. Today we will be talking about Lesson 11, the most important property of logarithms. The opening exercise does a good job of reviewing the main takeaway from yesterday, so I'm just going to do a couple of examples with you. In this example, we're given a log table, and for example, with B, we would rewrite log of 7,000 as log of 10 to the third times 7. Okay, so if we can convert this into scientific notation and break it apart. Yesterday we learned that if we just had the log of 10 to the third, it's 3. And then we can add it to the log of 7. So this was applying the property that we worked with yesterday in lesson 10. And so now I do 3 plus, and then I go to my table. I find that the log of 7 is 0.8451. So 3 plus that is 3.8451. If I look at letter C, it's obviously a little bit different. When I rewrite this in log form, I get log of 6 times 10 to the negative 5. Okay, because I would move that decimal place 5 times to get it past the 6. You'll notice that I did write it in the different order this time, so whether I do 10 to the third times 7 or 6 times 10 to the negative 5, order doesn't really matter. The exponent of the 10, again, I would be thinking about it of taking log of 10 to the negative 5. And we learned yesterday, anytime we have that, it's negative 5. It is that exponent. And then I do plus the log of that number, so log of 6. So in this example, I have negative 5 plus log of 6 was 0.7782. And when I added those together, I got negative 4.2218. So again, this is just an example of how we would use these properties that we talked about in lesson 10. Today, we're going to move on to the next page and start to look at some new properties. And you'll see I filled in the log table for you first. This log table actually, you can just copy down. We don't need to take the time to fill that in. We'll do that later. But now what they're asking us to do is to calculate these values using the log tables. So for example, in 2a, it says, find the log of 2, which is 0.3010, add it to the log of 4, which is 0.6021. When I added those together, I got 0.9031. Now it also asks me if that answer appears anywhere else in the table. So for log 2 plus log 4, I got 0.9031, and then I look at my table, and I see that it was the same. So yes, it appears elsewhere. It was the same as if I just took the log of 8. So I'd say take a few minutes now, pause the video and go through and try the other examples, and then I'll show you kind of how I walk through them, but I would practice it. So when I did log 2 plus log 6, I got 0.3010 plus 0.7782. When I added those together, I got 1.0792. When I looked at the table, I noticed that that was the same as log of 12. So yes, it was the same as log 12. And virtually what this example is having me do is it's having me go through and calculate a bunch of different things, and we're going to be exploring patterns. So in this case, I got 0.4771 plus 0.6021, 1.0792, which again was the same as log of 12. So again, as I go through all of these, I'm just going to write for log 6 plus log 6, I got 1.5564, which was about the same, very close to, as log 36. When I did log 2 plus log 18, I got 1.5563, which was the same as log 36. And finally, for the last one, I also got 1.5563, which again was the same as log 36. So our job was to figure out what pattern do we notice. Okay? And in every case, what I can see is that the two things I'm taking the log of, if I multiply them together, it's the same as that. So log 2 plus log 6 is the same as log of 2 times 6, which is log of 12. And that pattern carries through for all these examples. Which leads us to another property, which is if I have log of x plus the log of y, noticing that they both are base 10 because they don't have a base, I can rewrite that as a single log, and that's the log of x times y. Now we can also use that both directions. We know equal signs work both ways, so if I wanted to figure out log of x squared, I would start with log of x squared. If I wanted to, I know that x squared is x times x, so therefore because it's multiplication, we're on this side now, I can rewrite it this way, as log of x plus the log of x, which actually then leads me to understand I have two of the same thing, so I could rewrite that as 2 times the log of x. Okay. Same thing, make a conjecture about log of x, y, and z. This was just to show us that it doesn't work it doesn't only work if we have two things we're multiplying. If I have the log of x times y times z, I can rewrite it as the log of 3 things added together. Log of x plus log of y plus log of z. So that's what that first activity was to get us thinking about. And now the application of it. What this allows us to do is that if we can break a number down to a bunch of prime numbers multiplied together, or numbers multiplied together that I have a log table for, then I am going to be able to figure out what the log is without a calculator. Again, using the log tables, which has been a common theme here. So when I think of 14, I think of 7 times 2, or 2 times 7. So I'm going to rewrite it as log of 2 times 7, which then allows me to apply this property, and I change it to the log of 2 plus the log of 7. And again, if I can go back to my log table, we can see that the log of 2 is 0.3010, and the log of 7 is 0.8451. So those are the two things I would add together. So come back here. This is equal to 0.3010 plus 0.8451, and my final answer is about 1.1461. So again, I would pause it and quickly go through and try B, C, and D, and then I will show the answers here. So this one I rewrote as the log of 5 plus the log of 7, which was 0.6990 plus 0.8451, which is about 1.5441. And finally, the last two I will just give you the answers for. For log of 72, you should have gotten 1.8573, and log of 121. So this one was 8 times 9. This one I did 11 times 11, and I got, the problem is the log of 11 was not on the table. Not on table, so I would need a calc. Okay. Then there's one more property that this lesson gets at. And so when we look at this, I filled in the left column table, or the left table, and now I would want us to go through and fill in a few of the right. So we know the log of 2 is 0.3010. Now I need to type in the log of 1/2, and I got negative 0.3010. We know the log of 4 is 0.6021. When I typed in the log of 1/4, I got negative 0.6021. I bet you can't guess what the log of 1/5 is. Hopefully you were thinking, since the log of 5 was 0.6990, you would get negative 0.6990. So if I take the log of 1 over x, I get the exact opposite, so the negative version of the log of x. So this would be negative 0.9031, negative 1, negative 1.2041, so on and so forth. So I think you get the idea. And so the pattern that shows is that if I take the log of 1 over x, it is equal to the negative times the log of x. Okay, so just take the opposite of it. Number 8 just has us go through a proof of it. We did that in class, but I'm not going to take the time to do that here. Last but not least, there's just a few examples that we can practice using this idea and kind of putting everything together. So these are the big picture examples that we want to be thinking about. The first thing I noticed with letter A is that it's a multiple of 100. So I rewrote it as log of 100, or 10 squared, times 21. Okay, so first we're able to go back to the property we learned in lesson 10 that we reviewed at the beginning of this lesson. And so now I could rewrite this as 2 plus log of 21. And again, we have to use our log tables. So I need to now think about log of 21 the way we talked about it today. So 2 plus log, I know 21 is 7 times 3. So I can rewrite it like that. And now finally 2 plus, I apply our property of today of log of 7 plus log of 3. And then I would go back to my log tables. I find that the log of 7 was 0.8451 and the log of 3 was 0.4771. So I get this to be about 3.3222. So you can see that these properties we've been learning over the last couple lessons start to build on each other. So again, in the next one, the letter B. So I'm going to change it to log of 10 to the negative 5 times 49. Because then I can take that exponent out and I rewrite it as negative 5 plus log of 49. And I know that negative 5 plus, now I have to deal with the 49 because that's not in my log table. 49 is 7 times 7. So I could rewrite it as negative 5 plus log 7 plus log 7. And now I look up log 7 on my log table. And I get 0.8451 for both of them. So we get a final answer of about negative 3.3098. Okay, so again, I would recommend pausing it and trying the last couple of examples on your own. This next one, I rewrote it as log of 10 to the 6th times 42. Which was 6 plus log of 42. I know 42 is 6 times 7, so I do 6 plus log of 6 plus log of 7. So you can see I skipped this in-between step this time. You are free to start doing that when you recognize the patterns. 6 plus log of 6, I look up on my log table, is 0.7782 plus 0.8451. And I add those together, I get about 7.6233. So A, B, and C are all very similar. And D starts to look a little bit different. And now we're going to use that idea of the last property we talked about, that if I have the log of 1 over x, it is equal to negative log of x. So the x in this case is 640. So the first thing I do to rewrite it is rewrite it as negative log 640. Keep the negative in front. Log, again, I'm going to move my decimal place, 10 to the first power times 64, which gives me negative, and I'm going to put parentheses because I need to make sure that the negative applies to the whole thing. For the 10 to the first, it's a 1 plus log of 64, which is negative 1 plus log of 8 plus log of 8. Because 64 is 8 times 8. So I have a negative 1 plus log of 8 is 9.9031. So my final answer is negative about negative 2.8062. Okay. So today was a great lesson to start tying all these properties together. You'll see that these second and third bullet points in the lesson summary, these two properties are two that we want to add to our tool basket of ways to solve log problems using log tables. The homework for tonight is numbers 1, parts A, B, H, I, J, O, P, and then all of number 2, all of number 3. Thank you.